Okay, let's start. So we're here today, navigating decarbonisation. This is the fourth in our series. Previously, we've had problems. We've firstly gone through the EEXI, CII, and the EU ETS emission trading scheme. Today, we're going to be focusing on a different area. We're going to be focusing on alternative fuels. Now, the reason why we're focusing on alternative fuels, the IMO has set a target for 2030, and that's to reduce CO2 emissions per unit of transport work as an average across international shipping by at least 40% compared to 2008 levels. That regional emissions trading system, such as the EU ETS, may be even more stringent. So we're basically going to need to lower our carbon emissions within shipping. And that's why we highlight this particular section here, the carbon, and that's what we're looking at here. The way to reduce carbon emissions, one of the potential methods is to look at using lower carbon fuel options. And that's why we come onto this slide here, and some of you may have seen this before, but we just want to highlight to you what's going to be happening over the next few years and how this is measured throughout the industry. Bearing in mind as we look at this now, this area here is where it is being measured presently. So at the minute, it's tank to wake, which is measured for CO2 emissions. So it's looking at a very small part of the operation. Now, as time moves on and EU ETS and also the IMO, we'll be looking at it from a well to wake analysis. And what that does is allow for the whole process completely from start to finish. So you can see here that not only is it about the fuels that are used, for example, hydrogen is zero carbon atoms in the hydrogen, it's fuel itself. But if your production method is carbon intense, then it means it's matterless, the difference that you're making. So it's very important that the all this part of the process is carefully measured and there's no extra carbon input into the equation. So that's where that comes from, and you'll see this mentioned throughout as we go throughout uh, this particular topic. Now, what we want to look at here, we're looking here at crew training. We're looking to the future, and this is why I brought the DeLorean car here, the time travel machine. Ideally, we would like to look and see what happens in the future and which type of fuels are going to evolve, but it's very uncertain at the minute. There's only some fuels that are becoming to the forefront now, but there's going to be a lot of changes as we go through the next year. And really, we need a time machine to go ahead, look at what fuels are going to be used, and then come back and develop crew training. But we can't highlight crew training enough and the importance of this. We show the DeLorean here because this in 1985, 37 years ago, Dr. Emmett Brown was perhaps onto something because nuclear powered plutonium fusion reactor within the car produced 1.2 gigawatts, which would be great on a container ship and enough to power many different vessels. But nuclear is something that we may see used in merchant vessels, and that's something we'll discuss in a separate webinar. But just to bring to the forefront here that there's a lot to be thought about with respect to crew training. And this is where the IMO, the Maritime Safety Committee 104, a proposal of a new output, comprehensive review of the International Convention of Standards of Training, Certification and Watchkeeping. And what they're doing is the development of the training because they believe there's going to be a misalignment between the IMO instruments in respects of which regulations come in and how quickly that can be passed on to the crew. And that's a very important point. What we'd like you all to think about throughout this process is as soon as you start deciding which fuels you're going to use, then please consider crew training and get that in hand as early as possible. And that's what this MSC, this Maritime Safety Committee, recognizes. It recognizes the difference between the misalignments of dates of entry into force and the provisions of standards. Hands-on experience is something that is, we all know, is second to none to gain the relevant experience in the area. But hands-on experience isn't possible at this moment in time because, for example, hydrogen fueled vessels or other types of vessels aren't ready and they aren't in circulation. If we look at LNG, for example, what we see some of the larger LNG container carriers doing is bringing in external expertise and sharing that growth, the organic knowledge growth across the company. So chief engineers and masters come from LNG carriers and pass it on to the container vessels. But we're not going to have that luxury with a lot of these alternative fuels because they're just going to be coming out and then we're going to need the crew for them. So it's something that we think is a big concern and something we suggest is concentrated on. This just gives you an idea of all the different types of fuels and just shows you it's a bit of a roulette. We don't really know. And there's many different factors coming into it. Trading patterns, infrastructure, energy density, the age of your vessel, and many different things will influence what you're doing. So it's really hard to say at this moment in time which fuels are going to take off. There's many different variables, and what we will say today is that we're going to look at biofuels, blends, and methanol, just as two of the potential options. So let's look at a case study here. What we've done is case study. We've tried to bring to the forefront what could potentially happen, the sort of inquiries we're seeing from our members and how we can try and help them. So this case study in particular, Eco Warriors are the charterers, climate alignment, and they're using lower carbon fuel, so a biofuel, biodiesel blend. And the time charters arrange a stem of B30 BioVLSFO. Just for those of you that are not aware, B30 represents the renewable percentage within the fuel. So for those of you that drive cars in Europe and the UK, if you go to the pump and you put a B7 diesel in, that means that 7% of that fuel is renewable, and therefore you're cutting your CO2 emissions by using that 7%. In this case, we've got a trusted supplier for the successful in a successful previous trial, and spares and repairs were provided to the owners throughout this period. We then look at the case study, and we've got good commercial relations with time charterers, spares and repairs are provided, successful biofuel trial on sister vessel, certificate of quality has been requested from time charterers but not provided. That's important to note here. It hasn't been provided. And no additional testing carried out, and no wax appearance testing or wax disappearance testing, which we'll hear about further from Steve B. No objection letter from engine makers, which is also very important, and it's a point to consider. And the vessel was in special survey in 2021, but tank cleaning wasn't carried out. We just want to also bring to the forefront here, and I think what you're going to find throughout this presentation is that water really is the enemy with biofuels. It is the big enemy, but we just want to show you here the amount of fuel oil and water interfaces, and this is just some of them. It's not all of them, but it's possibilities where you could get water into your biodiesel blend. So it's just something we want to avoid. With that, I'm now going to ask Steve B to comment on a few of the potential tests that could be taken by ship staff and can be taken ashore in preparation for use of biofuels, and just what you can do, how you can prevent yourselves from problems as much as possible. Thank you, Steve.
Thanks a lot, Mark. Hi, I'm Steve B. I'm the Group Commercial Director for VPS. VPS are the world's largest and leading marine fuel testing and advisory company. Okay, so I think it's safe to say in recent years, shipping's attention has definitely turned to the goal of developing a more environmentally focused sector and reducing its overall emissions. SOx, NOx, and particulate matter all have legislative drivers to support a decrease in such emissions. However, I think it's worth noting that the maritime sector emits to atmosphere 940 million tons of CO2 per year and contributes around about 3% of global greenhouse gases. Therefore, as a consequence, the IMO has needed to set challenging targets to reduce such emissions. This equates to reducing greenhouse gas emissions by almost 500 million tons over the next 28 years. There are many possible contributing solutions to reducing CO2 and greenhouse gas emissions, but fuel choice will definitely be a major factor. One imminent piece of legislation is the introduction of CII and EEXI from the 1st of January next year. By 2023, the reduction factor will be set at 5%, with continuous improvement expected thereafter. VPS can assist here with our Maris decarbonisation software and well-to-wake CO2 calculator. Having said all this, for the next few years, the marine fuel mix will still be predominantly the traditional hydrocarbon fuels, but with increasing use of biofuels and methanol as time progresses. There has been some increasing interest in biofuels over the past 12 to 18 months, with VPS now having tested well over 400 different biofuels so far. We've undertaken a lot of R&D work on behalf of suppliers and many trials with ship operators with very positive outcomes across the board. Biofuels contain bioelements from various sources such as rapeseed, palm oil, soybean, waste oils and fats in the form of fatty acid methyl esters, hydrogenated vegetable oils, or hydroprocessed esters and fatty acids. There are numerous types of biofuel. You've got the first generation, which are made from food crops, with typical CO2 reduction of anywhere between 36 to 62%. But these fuels actually raise a humanitarian argument as to whether the crop should really be used as a fuel source in preference to feeding a starving population. The second generation biofuels are made from waste products such as used cooking oil, with a typical CO2 reduction of anywhere up to 88%. Then we have the third generation, which are made from algae, with typical CO2 reductions of anywhere between 75 to 90%. When we consider biofuel testing, ISO 8217 is still a very good starting point in terms of quality assessment. We see flashpoints which show good compliance with SOLAS. Viscosities can be wide-ranging from low center stoke levels to a couple of hundred, but in the main, viscosities tend to be at low center stoke levels. Cold-fold properties are a real issue with gel and wax precipitation across biofuels and bioblends, respectively. Therefore, pour point is a key test, along with the additional information which can be provided by wax appearance temperature testing and wax disappearance temperature testing. We found that the higher the bio content, the less sulfur is present. So with B100, for instance, these fuels are pretty much sulfur-free. And then if we look at FAME, FAME is made by reacting triglycerides with methanol. Therefore, the testing of glycerol and glycerides in the finished fuel by gas chromatography is a key test to monitor their presence. If higher levels of glycerol or glycerides are present within the fuel, then you may see deposits and fouling, which can affect obviously vessel operation and performance with injectors, filters, and fueling system blockages. Copper corrosion testing is a key to prevent any acidic corrosion potential. Alcohol content testing detects the amount of unreacted alcohol in the finished fuel. And of course, FAME testing, oxidation stability, ash, and certainly bacterial yeast and fungi tests are also key tests. Biofuels do have compatibility issues when coming into contact with certain materials. Stainless steel and aluminium are fine, but brass, copper, and zinc are not. Elastomers such as nylon, Viton, and Teflon are all okay, but natural rubber, neoprene, and nitrile material can all deteriorate in the presence of biofuel. In addition, polyethylene, polypropylene, and PVC should be avoided. FAME has numerous disadvantages, such as an affinity for water, emulsion formation, the generation of microbiological growth. But we see biofuels exhibit poor long-term stability with a shelf life of around about 3 months. Biofuels can be used in existing engines with little to no retrofit capex, but currently these fuels have limited availability and are at a higher price. However, having said all that, VPS findings with marine biofuels so far is that they are a good fuel, they are fit for purpose, and a viable means of actually reducing CO2 emissions. When we talk about methanol as a marine fuel going forward, we should really be talking about renewable methanol. And there are several pathways to produce renewable methanol. You've got the biomass pathway, where organic matter undergoes fermentation or gasification to produce a synthetic gas that is processed in a reactor and formed into biomethanol. You've then got the electro-fuel pathway, where renewable electricity is used to extract hydrogen from water by electrolysis. Hydrogen is then reacted with carbon dioxide captured from exhaust streams or from the atmosphere. The renewable feedstocks can come in many forms: agricultural waste, forestry residues, municipal solid waste, and of course, renewable electricity. Methanol itself burns with a good clean flame, has good combustion characteristics, but does require a pilot fuel. A few pros relating to methanol are: firstly, it's actually a liquid at atmospheric pressure, so handling is easier than LNG or hydrogen. Plus, it's fully biodegradable and can run well on existing engine technology. However, some of the cons relating to methanol are that it's got a very low flash point, 12 degrees centigrade, and a relatively low energy content compared to the traditional marine hydrocarbon fuels. Key testing considerations for methanol are listed on the slide here, with calorific value, methanol content, water content, ketones, chloride, acidity, sulfur testing, and purity and impurities testing via GC or UV are all key tests. Methanol can provide 30% less NOx than diesel in order to achieve the Tier 3 NOx requirements, and adding water to methanol can actually reduce the NOx. The water quality, however, will be very important, and the vessels need to be aware of the potential corrosion water can produce within the combustion chamber. And with that, I'll hand you back to Mark. Thank you.
It's a great intro to methanol, which will be my topic for discussion. I'm the chief operating officer for the Methanol Institute. We're the global trade association for the methanol industry. And I'll share a bit of a background with you just to kind of maybe bring you up to speed on some of the gaps. And then we'll talk a little bit more about safety, safe handling, and some of the technical measures around methanol as a marine fuel. So it's worth noting that natural gas is still the predominant feedstock for producing methanol. It's largely produced by coal in China, and we have a very nascent yet rapidly growing sliver of that installed capacity pie, which is focused on renewable or biomass-based methanol production, and it's going almost equally into chemicals as well as the fuel sectors, with the fuel sector probably growing the fastest. It's split almost in half at the moment. You can see the largest sector now is kind of split between MTO technology, which is purely a Chinese based technology, and formaldehyde, a very traditional market. But it's been used as a fuel additive in fuel markets for decades. With about 100 million tons of installed capacity, there's roughly 32 million tons traded internationally, and out of that 32 million, 33 million tons, almost half of that, about 13, 14 million tons, is imported to China on an annual basis. But it's got a fairly diversified consumer base, as you can see here, which reflects on pricing, on predictability, and it maintains quite a high quality consistency. And as we begin to move into, as you may have heard, the terminology blue, green, or gray fuels, whether we're talking about ammonia or methane or hydrogen or methanol, you can see here that much depends on the source of feedstock. In methanol's case, we're not only sourcing from, say, natural gas, but also there's biomass, there's electrolysis for the production of renewable methanol, and there is also a kind of an argument going on between the use of what's considered renewable CO2 or non-renewable or industrial CO2 that's captured. But nonetheless, IRENA, the International Renewable Energy Association, has predicted that by 2050, methanol production will grow back a factor of 5 from today. And you can see that that's largely based on the premise that e-methanol, or methanol which is produced via the electrolysis pathway, will probably be an overriding technology factor with biomass which could mean anything from forestry or agricultural residues to even, say, municipal solid waste as a feedstock. But at the moment, yeah, you can barely see on that left column just a sliver of e-methanol being produced currently, but under development on paper, and actually with a few plants already producing, we're looking at over the next roughly 18 months or so, 2 years, somewhere in the neighborhood of about 1.2 million tons per annum. And this is important and interesting when we talk about bringing this type of methanol, which is more expensive than conventional methanol, just as green ammonia or green hydrogen or biomethane would be more expensive than their ammonia, hydrogen, or LNG counterparts produced in a conventional manner. And you can see why here. There are benefits. There are maybe disadvantages depending upon what the exact application will be and what the type of vessel will be. But you can see on a volumetric basis, even methanol is can bring about the same amount of energy on board as LNG. So it's just a different way of looking at it when you are ready to make a fuel selection or fuel switch. And looking at the properties from of these various fuels from an emission reduction perspective, which is the criteria by which you will be justifying the premium that you're going to have to pay for these cleaner fuels. You can see that pretty much all of them will reduce SOx, PM. Methanol is capable with emulsification technology, which is already classed on the manned vessels, as well as the forthcoming Wärtsilä engines. It can reduce NOx by up to 80%. But at the moment, all regulation is based on tank to wake, which was already stated. However, beginning June with MEPC 78, I think we can look forward to seeing some new legislation introduced to address carbon levies, perhaps LCA basis or life cycle assessment basis for looking at fuels, which means looking at these different emissions profiles on a CO2 equivalent basis. And I think just one note regarding quality: methanol is currently traded internationally based on the IMCA standard, which is a 99.85% purity. So methanol itself is a highly pure molecule to begin with. And then pharmaceutical grade, of course, is even more pure. Fuel cell grade is even one up on that. The IMO has already mandated the ISO to develop a standard for methanol marine fuel, which that work is ongoing. We expect perhaps by the end of this year for that standard to be introduced. But I think it's safe to say that it will begin at this quality level of some 99% plus, and come down by an equivalent amount depending upon what it's being blended with. As was mentioned previously, methanol is completely miscible in water or other liquids. That's what lends itself to be such a premium fuel from a combustion perspective. And I think that standard will reflect that technical framework. And I guess that's it for me. I think I had a couple more slides, but that's it. So thank you very much. Appreciate your attention.
Thanks.
Thanks, Chris. Good day to all. I'm Edwin Pang. I'm founder of a consultancy called Auxilia. We work very closely with the IMO, European Commission, EMSA, IX members, shipping trade associations, and ship owners on the regulatory policy aspects of decarbonization. Very short presentation on a couple of aspects of biofuel which may or may not be immediately obvious. Many of you would have probably read about or even trialed the use of biofuels yourself, and there is a lot of pressure on this because of customer requirements, both Scope 1 and Scope 3 reporting. as many logistics providers and supply chains seek to decarbonize and show proof of this or demonstrate that they have done this. Unfortunately, the regulatory position is somewhat complex and evolving. The bit here in red is you can probably demonstrate GHG reduction for customers if you use biofuels. The issue is that when it comes to reporting to the various schemes, so that's the IMO DCS, that's the EU MRV, potentially then it becomes the ETS and the Fuel EU Maritime, the treatment of biofuels is very different. With MRV, with approval of your verifier, you can assign biofuels a lower carbon factor. With Fuel EU Maritime, the calculations may be a little bit different, and we're still not quite sure how ETS is going to pan out. But for the IMO DCS, particularly for CII compliance, biofuels don't make a difference, at least not officially, because the IMO carbon factors that are used are tank to wake only. There have been some reports in the DCS where waste cooking oil has been given a carbon factor of 0, but these seem to be trials or errors or interpretation issues. So the current situation is officially biofuels are treated no differently than their fossil equivalents in the IMO DCS. So if you're looking to biofuel for CII compliance at the moment, it probably doesn't work. Now, yes, we will begin discussion of the life cycle analysis guidelines at ISWG GHG 11 in March. However, the passage of legislation through the IMO is somewhat lengthy, and at the moment there is no intention for the guidelines to be used for CII yet. So the process at the IMO is that we will agree life cycle analysis guidelines first, and once those have been agreed, which will take time to come into use, we have to decide how we will apply them, and that how, particularly if it involves use in the CII and amendment of MARPOL Annex 6, takes several years. So that's the timescale in terms of what happens with recognition of biofuels within the IMO DCS and CII and any associated IMO instrument. The other thing you will come up to face would be that biofuels are treated slightly differently from NOx. So in MARPOL Annex 6, fossil fuels are treated slightly differently from non-fossil fuels. And therefore, any existing engine that uses biofuel must demonstrate compliance with MARPOL Annex 6, Regulation 13, and the NOx Technical Code. And this is sometimes challenging, or most of the time, because it requires onboard emissions testing. And Regulation 18 also treats non-fossil fuels more strictly than fossil fuels. So there have been some submissions to the IMO, to MEPC, both at MEPC 76 and 77, addressing these issues. So regarding onboard emissions testing, their external environmental factors is not possible to reproduce bench conditions in the field. And there are a few other issues regarding how the testing should be conducted, how long the testing needs to be conducted. And all these means that just in order to try one fuel, it's suggested it might require more than 6 months. Now, this means that having to prove compliance by in-service testing is somewhat complicated and expensive. Now, the proposals are that, and this has not yet been discussed or agreed, but these are proposals to help the passage of use of biofuel, is to invite flag states to issue temporary exemptions for ships conducting biofuel trials, to treat blends up to 30% biofuel as fossil fuel, i.e. B30, and to allow 10% allowance of the applicable limit when testing on board. We don't know if these proposals will ultimately be taken up and implemented, but certainly these will help sort of further adoption and use of biofuels if they are taken up. One last note, a recent biofuel trial, just to illustrate the complexity, going back to carbon factors, up to 4 or 5 different carbon factors were calculated for that blend of biofuel. And that just illustrates the potential interpretations that are out there regarding how biofuel is treated in the regulatory regime. Thank you.
Thank you very much. Thanks, Edwin, Chris, and Steve for your section. Very interesting. So the next part now, we're going to go back to this case study that we opened up before. We're going to show you what we've seen happening, not only what we may see happening with biofuels, but what we've seen happening a lot with very low sulfur fuel oils. And obviously, if we're looking at a biodiesel biofuel VLSFO blend, you may experience these problems as well as the problems that you're going to get with biofuels. So it's just important to note, and what we're seeing is blocked fuel transfer systems, purifier sludging, and blocked filters, and vessels in this particular case study may not have enough distillates to reach the next port. And also, we may have time-sensitive refrigerated containers on board. So that's just another point to take into consideration if the vessel loses power and if the vessel can't use its fuel. So in this particular case study, what we're looking at is a vessel which loads cargo in Sydney, effectively then sails to Auckland and Wellington, and then the intended voyage is to deliver all of these containers, including refrigerated cargo containers, to Lisbon. Unfortunately, in the middle of the voyage, we get a problem with the fuel system on board. We get a problem with the blocked fuel system, so we can't then proceed. And it's a long way. It's nearly 6,000 miles between these two points here. So the ship has to continue to a port of refuge. The fuel's debunkered. New owners are looking at bringing their claims for losses against charterers. So let's look firsthand at how this may play out. At this point now, I'm going to hand over to Helen and Roma, who consider the case study further and put forward some arguments that both owners and charterers may raise when dealing with such a matter. So it's over to you now, Helen and Roma.
Thanks, Mark. So, as Mark has mentioned, Roma and I are going to run briefly through this case study. I'm going to take owner's position, and Roma's going to wear her charterer's hat. Just to briefly introduce myself, I'm in North's FD&D team in our Newcastle office. I work mainly with European and UK members, but I am also on North's decarbonisation working group, and we've been getting various inquiries from members in relation to the upcoming regs, and more recently some inquiries in relation to biofuels. I'll just pass to Roma to introduce herself before we kick off with the case study.
Hi everyone, my name's Roma Williams and I'm a senior executive in North's P&I team. I'm also based in the Newcastle office, and I work with owners and charterers, but have dealt quite a lot with charterers issues, particularly in respect of fuel.
Thanks, Roma. Kicking off the case study then, the fuel stemmed by charterers has caused a major problem for the vessel. Owner's position is that the responsibility is with charterers, so they are responsible under the charter party terms for providing and paying for the fuel, and providing that fuel to the required specification. The fuel has caused a blocked fuel transfer system, so the fuel can't transfer from the tanks, and the purifiers are sludging heavily with the blocked fuel filters. So this off-specification fuel has caused a significant incident for owners, as Mark has explained with the MAP case study. And consequently, there are considerable costs that have been and will be incurred by owners, including having to get the vessel towed to the next port, where the fuel can then get debunkered and new suitable and on-spec fuel stemmed, so that the vessel can then proceed on her voyage. So in summary, owners' losses end up being or including hire. So charterers place the vessel off hire from the point at which the fuel could not transfer to the tanks. And so there's a significant amount of hire outstanding from the charterers. Towage costs, port costs, debunkering costs, tank and fuel system cleaning, as well as sludge removal, cargo claim for the time-sensitive refrigerated cargo that Mark had mentioned, which had been valued at 5 million, sampling, testing, expert surveyor and correspondence fees, and also crew labour costs for purifier cleaning and filter cleaning. So the owner's position or starting position is that these costs are for charterers. And in terms of passing these costs on to charterers, we have to look at the charter party terms as well as the evidence. So while this is a biofuel blended VLSFO, no specific clause was actually agreed with charterers to burn or stem biofuels in the charter party. So the wording that is agreed between owners and charterers in the charter party is sort of standard wording in terms of compliance with ISO 8217, and it's the 2010 version in the charter party. That said, there is additional wording along the lines of the BIMCO bunker quality and liability clause that requires the fuel to be of a stable and homogeneous nature and suitable for burning in the vessel's engines. So that's an added layer for owners. In terms of a binding sample for determining whether the fuel is off specification, there is no specific sample stated in the charter party, which means that there is no limit on the number of samples that can be tested to try and determine the liability for the dispute. So firstly, the points that owners are going to be raising against Roma or against charterers initially is, firstly, our view is the fuel you provided is off specification. So while the initial sample may have shown that the TSP was within spec, it very close to the limit at 0.09%, because it's so marginally in spec, we believe that actually if further testing is carried out, that's going to show that the TSP was in excess of 0.10% and therefore off specification. Also, even if the TSP is within specification, which we deny pending further testing, the fuel is clearly not suitable for burning in the vessel's engines given the issues it has caused. And fuels with a high TSP can be indicative of unstable fuel with a tendency to precipitate sediment and sludge, and that is exactly what's happened in this case. As per the charter party terms, not only does the fuel need to be within specification for the ISO 8217, it also needs to be stable and homogeneous, and our view is that this fuel is not. And I will pass to Roma for her first response.
Thanks, Helen. Hang on a second, because I don't think that owners have established that this is a problem with the fuel at all. Owners can't simply sit back and point to charterers because that is convenient to them. Owners' vessel manifold sample is on spec, as you've already said, with a result of 0.09% for TSP. The binding sample, as agreed with the suppliers in the bunker supply contract, is also clearly on spec. That obviously establishes that charterers have provided fuel that's compliant with the charter party specifications. We therefore believe that the problems that owners have experienced can only be as a result of the way that the fuel is handled. In that case, all liability for these high losses that you're trying to claim from charterers will actually sit with owners. We've supplied on-spec fuel. Owners can't then simply sit back and point to charterers as this being their problem. So the problems that owners are complaining of, blocked filters and sludging. We know that with biofuels, water ingress into the fuel can cause microbial growth, which leads to the same issues that owners have complained of. So that's something that we're going to be looking at and we'll be asking owners to rule out. The analysis of the barge sample and of owners' vessel manifold sample both show that the water content for the fuel supplied by charterers was well within specification. So if we subsequently find that there is an increased water content in the fuel now and any resulting microbial growth, that is clearly, again, due to the poor handling of the fuel by owners. So it'll be their liability and it won't be for charterers' account. Even if further testing doesn't show that there's been any water ingress, then we still believe that there's been a failure by owners to properly manage and handle the fuel, and you're going to have to counter that. For example, we understand that owners didn't do any additional testing for wax appearance temperature and wax disappearance temperature. Had owners done this, then they would have known what temperature to heat the fuel at and handle it to. If owners have heated the fuel too much, for example, this could have led to distillate aging, which would also increase instability in the fuel. We also understand that tank cleaning wasn't carried out at the vessel's last dry dock prior to this fuel being stemmed, and we will maintain that that would have been the prudent thing to do, because there could have been previous fuel residues and compatibility issues with any fuel remaining on board. I'd also highlight, as you've already said, that owners did know the TSP results before they decided to use the fuel, but they decided to go ahead and use it anyway, and presumably they did so bearing it in mind and handled it appropriately given what you would describe as high TSP levels. So in conclusion, we will be arguing that it's very clear that charterers have provided on specification fuel. The problems experienced have been caused by owners' handling, and to the extent that owners have had to remove the fuel or they've experienced any losses as a result of main engine breakdown, this is all for owners' account. So I'll hand back to Helen, who will counter those arguments. I think you're muted, Helen.
Thanks, that'd be helpful. Thanks, Roma. So from what charterers have said, the charter party terms and the charterer's supply terms as to what is the binding sample are not back to back. So just because you've agreed a particular binding sample in your supply contract doesn't mean that that is evidence that the fuel is on specification. And so just because, say, for example, it's the barge sample under the supply contract and the sample noted on the BDN that's binding for liability purposes, that is not the case under the charter party. And it'll be a case of evidencing with representative samples that the fuel is on spec, and owners maintain that that will be the case once this further sampling and testing takes place. The crew are well experienced and competent with handling fuel. There's absolutely no evidence that the fuel was handled incorrectly or that water has entered the fuel due to the crew handling, or indeed that the fuel was heated to the wrong temperature. And so we put charterers to proof on any of those allegations that they've raised. We have, of course, appointed an expert, and their view is that the issue with the sludging is in keeping with high TSP results. They expect that it is most likely as a result of a high TSP fuel. And our expert has proposed that further sampling is taken from the tanks now that the vessel is in this port of refuge before the fuel is debunkered. And so we invite charterers to attend the sampling and witness the testing. Thank you.
Thanks, Helen. That's certainly a sensible way forward, and I think charterers will agree to that approach. However, we will maintain that the initial commercial sample tested by the owners and the barge sample tested by the supplier, both of which show TSP to be within spec, are evidence that charterers have provided on specification fuel. We've also appointed as an expert, I'm sure that won't come as a surprise, and they advise that actually TSP at the level shown in the analysis would not have caused the issues. So the problems experienced must have been as a result of poor handling of the fuel. So clearly our experts disagree on that. Charterers expert also agrees to further sampling. We expect that will show an increase in water content, so we're more than happy to proceed with the analysis that you've suggested. We also are aware that there's a possibility that the fuel was blended with a small quantity of remaining on board fuel in the vessel's tanks, and we're going to argue that that contributed to the sludge deposition. So we would also like to carry out sampling to investigate that further. So we suggest that the surveyors attend on board the vessel to inspect the fuel oil transfer system in more detail. We'll want samples of the material collected in the filters, which should be properly sealed. And we believe that samples of that sludge will evidence that the sludging has not been caused by the fuel itself, but as I keep saying, the questions that we've raised over the fuel management once it was on board the vessel, which would not be a charterer's issue. We'll also be asking owners to provide copies of documents, and obviously I'll follow up with an extensive list of documents as recommended that we obtain by our experts. So just to give you an idea of the type of documents we'll be requesting, We'll want the engine logbook for the period that the bunkers were in use. We'll obviously want to know the dates when the vessel started consuming the bunkers. We will want the temperature records of all fuel tanks, including in the storage and settling tanks. We'll want tank cleaning reports, and so on. As you can see, the list is going to be quite extensive, but I'm sure your experts will agree that's reasonable in the circumstances.
Thanks, Roma. So owners are very pleased that charterers are going to attend the sampling and testing, and that should assist to ensure there's no dispute that can be raised as to sampling and testing by charterers further down the line. As for documentation requests and access to the vessel, obviously please do send that list through, and while owners have absolutely nothing to hide, we'll be giving such requests careful consideration with input from our expert, as charterers can't obviously embark on a fishing expedition. So just to wrap things up, because I'm conscious of the time, at this point the case study moves on, and additional sampling and testing has taken place, and the results do show slightly increased TSP compared to the original sample at 0.11%, which is slightly off specification, and increased water content. So how this matter proceeds, for example, whether to settlement or arbitration, will obviously depend on the parties and the evidence. Owners will maintain their argument that the fuel is off-spec and unstable when stemmed, and charterers are focusing on poor fuel management and notably the increased water content, and perhaps also the fact that the increased TSP level is not reflective of the TSP when the fuel was actually stemmed. So both stances, as you can see, are very technical in nature and are going to rely heavily on expert evidence, which is cost heavy. It also means increased litigation risk, and there may be hidden issues that also emerge as the matter progresses. Roma, I don't know if you've got any final comments to make.
No, I don't think so, Helen. I think you've covered all of the key points that we discussed there. And with that, I'll hand over to Michael Asherson for a summary of everything that we've discussed.
Good morning, ladies and gentlemen. My name is Michael Asherson. I'm a claims director in the P&I department with a focus on charterers' claims. So thank you very much, firstly, to Helen and Roma for that very instructive case study. Ladies and gentlemen, as will have been clearly evident from the case study presented by my colleagues, off-specification bunker disputes can be challenging. Both from the perspective of an owner or charterer, but also from the perspective of the club. Off-specification bunker disputes are often characterized by the following attributes. Firstly, these disputes can be technically and legally complex. In the case study, both parties require the assistance of surveyors and experts. In terms of experts, it is entirely possible that both parties would need advice from marine engineers and chemists. In other words, it is likely that there may be as many as 4, if not more, experts involved in the dispute, advising both owners, charterers, and possibly the bunker suppliers. In terms of the legal position, the contracts involved, such as the charter parties and bunker supply contract, are frequently not back-to-back in their terms and often contain conflicting law and jurisdiction provisions. Secondly, as will be self-evident, these disputes are very expensive to deal with. Given the number of experts involved, these disputes tend to be expensive to resolve. Each party in this case may require the services of 2 experts, as well as surveyors and correspondents for the purposes of sampling, and possibly even lawyers if advice is required on the contractual position and potential liabilities. And all of this before formal litigation has even commenced. Leaving aside the technical aspects, any litigation, as Helen flagged, which follows is likely to be both complex and expensive, requiring extensive expert evidence and carrying an element of litigation risk for both parties involved. As the case study illustrates, there are frequently arguments both ways in disputes such as these. Thirdly, off-specification bunkers can give rise to substantial claims. Aside from the usual charter party disputes relating to off-hire, lost time, etc., as we have seen from the case study, there is also the risk of significant cargo claims as well as potential salvage and general average implications in the event that the vessel suffers a loss of propulsion, which cannot be rectified during the voyage. Finally, and perhaps most significantly from members' perspective, these disputes can give rise to significant interruptions to the vessel's commercial trading schedule. Off-specification bunkers may impact on the vessel's commercial schedule significantly. Once a dispute arises, there may be substantial delays whilst the parties undertake testing in order to determine whether or not the bunkers can be burnt. In the event it is determined that the bunkers are indeed off specification and cannot be managed on board the vessel, a debunkering operation entailing further loss of time may be required. So, to summarize, for the reasons I have mentioned, it is vitally important that the scope for off-specification bunker disputes is minimized insofar as possible. How can owners and charterers reduce the risk of bunker disputes from the contractual perspective? Well, consideration should be given to charter party clauses. Those clauses are likely to evolve as we begin to understand more about biofuels. As will be evident, for example, from the case study, the governing charter party did not specify which sample was to be regarded as the binding sample. Careful consideration also needs to be given to fuel management. For example, there will be an operational need to prevent water content in bunkers due to the risk of microbial activity within the fuel. This may in turn require frequent draining of fuel oil settling and service tanks, prevention of water ingress into fuel tanks, periodical fuel system and storage tank analysis to check for microbial contamination. Of course, if detected early, microbial contamination can be treated with fuel biocide, but if left unchecked, it can give rise to fuel system choking, as we saw in the case study. Long-term storage of fuel should also be avoided. In the event of a dispute, the quality of the evidence collected and preserved will be critical. Consideration should be given to collecting physical, documentary, and electronic evidence. All evidence should be carefully preserved, and a secure chain of custody should exist. One must act quickly. Opportunities to collect evidence may be limited. And finally, be sure to check and preserve rights of recourse against bunker suppliers. Bunker supply contracts often contain very strict time bar provisions. Thanks very much. I'll now hand back to Mark, who will open the floor to questions.
Thanks very much, Mike, Helen, Roma, Steve, Chris, and Edwin. I really appreciate it. Good presentations there. We'll put this slide up here just so that anybody in the audience can, when we send the presentation across, you can see all of our email addresses. What we're going to do now is I'm going to stop presenting. We're going to all put our screens on, our videos on, and then we're going to go to a bit of a Q&A session. So we've got some questions stacked up in the background that we've already been asked on this subject. And if there's anything else, please put it into the chat. If the audience has any more questions, please put it into the chat. We're obviously mindful of time at the moment, but we'll continue at the moment until we hear elsewhere. Okay, so first of all, Chris, I don't think your video is on, just to let you know, by the way. It looks as though it's off at the moment. I'm just going to start off really, Steve. I just want to ask you quickly. We talk about the testing there, and I know you touched on it there, the testing, potentially testing on board and testing for microbial. We heard how it's really the enemy there. So I just want to hear a little bit about that, if it's okay, Steve, and what VPS propose and what can be done on board as well, you know.
Yeah, okay. I mean, obviously there are numerous test kits for various parameters which you can use on board. However, I think it's key to note that a lot of these are quite subjective. Obviously, again, requires training of crew members to take right samples and carry out those onboard tests accurately. But they will never take the place of obviously a defined laboratory testing, looking at obviously the repeatability and reproducibility aspects of the true ISO 8217 tests. So in that case, yeah, it may give an indication, but it wouldn't really hold, I don't think, much credence, certainly in a claims case. That's for sure. In terms of microbial testing, you need to understand as well, it does take some time for microbes to grow, and it does take time, obviously, for any corrosive action from that microbial growth. So, these things won't happen overnight. Will take time. But I think, in terms of the biofuel VLSFO blend, I think key parameters are certainly the cold flow property tests. So how to handle the fuel on board ship, the correct storage, etc. Those are key. Those are key tests in relation as well to the TSP and any other sediment tests, because you can either store the fuel too cold, in which case you get wax or gel precipitation, or you store it too hot, and therefore you'll start getting thermal degradation of the fuel. So it's trying to get that balance between the two.
Okay, thanks, Steve. That's great. There's a question coming there about what about carbon capture on board. We've written an article about this. So if you look on the Navigating Decarbonisation website in North, we spoke about the possibility of this in the future. There's a lot hinges on potential trading. There's certain vessels suit this, tankers, for example, because in enhanced oil recovery, utilizes carbon capture. So there is trials going on board at the moment on a Mitsubishi vessel. To explain it in entirety, I would suggest looking at our article, but there is a lot of concerns about the classification of it, the size of the equipment, the onward movement of the carbon capture effectively. So it's by no means a finished article, and I think there's going to be a lot of development over the next 10 years on that. But it is a potential alternative, something to look out for. That's what we'd say at the moment. I think the next question really is for you, Edwin, if I'm looking at it correctly. Did I understand correctly that you a biofuel?
Yes, thanks, Mark. I responded in the chat, but yes, Renee's question about whether biofuel influences CII performance. It goes back to what the IMO DCS was originally designed for, which is simply to collect or aggregate fuel consumption from a tank to weight perspective. So let me make it clear. At the moment, use of biofuel does not affect your CII result. You will find, or you may find, some verifiers or some ROs or some flag states who have a slightly different interpretation, or it's a mistake. So we see a lot of mistakes where a verifier or an RO does something for MRV and they transfer that lock, stock, and barrel to DCS, even though the two regimes differ. So officially, biofuels don't make any difference to CII. You may find that someone is willing to interpret it differently, but in which case you need to speak to your class society or your flag state.
Okay, thanks, Adam. Thanks. Sorry, I've just got another question coming there now. But there was another question on the carbon comparisons between methanol and biofuels. Now, there is going to be a lot of variation, as you discussed before there, Edwin, on the carbon factors. And it really depends on the complete process, and it's really hard to draw a direct comparison because there's going to be so many differences throughout the supply chain, feedstock availability, etc., etc. So it's not really that easy just to draw a direct comparison between the two, and there's going to be huge variables in between them. And that's really when we see the well-to-wake analysis coming into the equation, then we'll be able to give more of a refined answer on that. Let's say, I'd say at the moment it would be very hard to just give something on that, but yeah, that's what I'd like to say on that. Another question's coming here now from John Pierre. So biofuels, I think that's one for Steve. I think if that's okay, Steve, if I push that in your direction. If not, I can come back to it myself as well.
I think the point that John Pierre is making is true. I mean, you're always going to get atmospheric moisture. You will get condensation. Whether tanks will need to be redesigned or adapted, again, it could be quite a lengthy job. What I would advise is obviously just careful monitoring of the actual fuel and the tanks throughout any particular voyage.
Yeah. I think it is something to take into consideration. But I think the thing is, potentially I'd like to point out there is that a lot of the vessels that are using biofuels are probably going to be older tonnage moving on to use this. So actually carrying out any modifications, unless you've got a good life cycle left in the vessel, it may not be commercially viable. So that's probably what I would say on that. There may be new vessels which are built with biofuels on purpose, but personally I see it as more in the short term being used on older tonnage where there's not much else available and it's the most suitable option. So thanks for that. So we've got no more questions in the chat, but we've got some questions backed up. So the other questions that we have, really, I mean, we had a lot of questions on, what's the future what's the future alternative fuel, and that's really hard to say at this moment in time. We'd love to be able to give you the silver bullet here and send everybody out, but really, as I said before, as I touched on before, and as I just like to reiterate that there's so many different variables here. You've got trading patterns to take into consideration. You've got the type of vessel, the energy density. For example, fuel cells are suitable on short sea passages, but you can't quite get away with that technology on larger deep sea vessels at the moment. As we discussed before, the methanol energy content's not quite the same as others, and the same as a lot of other fuels as well. So there's many different factors taken into consideration, and it really does depend on each vessel design, each vessel type, where they're trading, and unfortunately it's back to the drawing board, and it makes it very hard for everybody because if we turn the clocks back to IMO 2020 and the price differentials that were predicted between your low sulfur fuel oils and your high sulfur fuel oils, and the viability of exhaust gas cleaning systems, that was thrown into the mix when the pandemic came along and price spreads changed. They closed in they closed in a couple of years ago, and now you see them opening up again. So really, it's very unpredictable. What I can say is localized schemes such as EU ETS may bring some refinement locally. It depends what happens on a global basis with that too, and what incentives and tax levies and research funds are brought to the forefront, really. So there's many different variables there. And I think that's it really for the moment on that. Just another question is really just quickly, it's to you, Steve, on ISO testing standards, just quickly. And I know you touched on it before, but just, what's your thoughts on it and how that's going to progress through the next few years, and, when's the next development with respect to biofuels going to come into the equation effectively?
As I said in the presentation, Mark, I think with biofuels in particular, ISO 8217 is still a good starting point. Obviously, a lot of the parameters there are still key to assessing quality, but without a doubt, additional testing will certainly be required. As I say, things like looking for the sort of triglycerides or glycerols, glycerides in a finished fuel would be key, because these components could potentially cause problems on board ship. Copper corrosion testing is another one. Also looking at alcohols, again, the alcohol content, because when you're producing FAME, fatty acid methyl ester, it's basically a reaction between a triglyceride, sort of fatty type oil material, being reacted with methanol. But this is actually a reversible reaction, so its temperature is key. An excess of methanol is required again to drive that reaction over to the right hand side of the equation, as it were. So there are a number of key additional tests which will be need to be considered. Now, obviously, with the ISO committee, I know obviously at the moment they are looking at obviously the next revision of the 8217 standard. I believe that's been slightly delayed to maybe 2024. At this moment in time, I wouldn't say there's any indication that biofuels will be included to any greater level than maybe what they have been in the past, but we will see. Obviously, there's a long way to go on that, but yeah, I think we do need some further understanding and direction in terms of biofuel use, because I think biofuel and also methanol will certainly increase in usage as a potential solution towards the carbon zero drive, and we need to have some regulatory responses there to help us obviously use these fuels in a more effective way and make sure that they are actually fit for purpose.
Thanks very much, Steve. Thanks. I think unless there's any more questions from the audience, we've gone slightly over on time. I know time is precious for everybody. If there is a question you've asked and we've not managed to massage it into the presentation, we'll come back to you separately or try and cover it where we can. Anything else, please feel free to reach out to any one of us that was on the call today. All our email addresses will be on a PDF that gets sent around. We look, by the time we get editing done and get the video out, we'd look to get it out to anybody who registered for this webinar within the next 7 days, hopefully. And that will have, like I say, all the contact details on. It'll have a copy of the recording, a copy of the PDF, and please feel free to reach out to everybody. With that, I just want to say thank you very much to all the panel. Thank you to everybody for bringing it and talking such an important topic here. And thank you for Helen and Roma. And they're normally not as aggressive with each other in the offices they were this morning. But quite interesting to see how it works from both the charterers and the owners' perspective. So very interesting. And thank you for Mike for giving the overview there. That's really good to understand exactly what's gone on and what it looks like from a higher level. And then just another question coming there. Oh, yeah, okay, so that sounds great. Yeah, excellent. So it's been answered. Okay, well, with that, thank you. Any more questions, please fire them to us. We're happy to answer. We're happy to help. Thank you very much to everybody for attending, and thanks again to all of the panel for all of their efforts with their presentations. Thank you, and goodbye.
Thank you.